Hello everyone. I wanted to go over a few examples on the remaining sections of chapter 10. Having some issues with my iPad, but now I have them resolved. So let me go over the remaining sections. So I want to start off with hyperbolas. This is the last one dealing with the conics. We did parabolas, we did ellipses, so now we're going to do hyperbolas. And then the next thing is, if you know the parabolas and ellipses and hyperbolas and the circles, then we can also do the rotation of conics, which is 10.5. So let's look at hyperbolas, how to write them in standard form, how to find the asymptotes, and then obviously how to graph them as well. Alright, so how is a hyperbola defined? Well, you have the set of all points, which is going to be these guys right here that are on the graph, right? This is the part that we graph. In a plane, and the difference of whose distances from two distinct fixed points, the foci, is a positive constant. So from here to here minus from here to here, if those are constant throughout, right, then we have ourselves a hyperbola. So that also goes from this side. So this distance and this distance, when you subtract them, and it's going to be the same from here to here, subtracting here to here. If those guys are the same, then you are on track to creating a hyperbola. Alright, so again, like the other ones, we have fixed points, which are our foci, and then we have a center, and then because they're hyperbolas, we have a vertex. Alright, so here we have the center, and then of course we're going to have a standard formula. So from the center to the vertex, that's going to be A. From the center to the focus, it's going to be C. Alright, now I want to point out this transverse axis. Alright, hyperbola can be, you can have a transverse axis that is horizontal, as this example, and then you can also have a transverse axis that is vertical, right? That just means that the center, the vertex, and the foci are going to lie on this transverse axis. If it is horizontal, then they're all going to have the same y value, so the x value is going to change. And if it's vertical, they're all going to have the same x value, and the y values are going to change. So if you want to pause this real quick just to write these down so you can reference them as we do an example on writing a general equation into the standard form of a hyperbola. So notice how it looks like an ellipse with the exception of this minus sign. Alright, this right here. So we have x minus h squared, y minus k squared. It's a fraction, it's equal to 1, so that's still the same as an ellipse. But when you have a minus sign, when you have this subtraction sign, then it becomes a hyperbola. Alright, so the a squared will always be with the leading or the positive component of this equation. So notice here it is x minus h squared, so that means that a squared is going to be attached to the x, which means you have a transverse axis that is horizontal. So in other words, it's going to open to the right and to the left. And then when you have y minus k squared, so then you have a squared associated with the y, which means it's going to open up and down. So you have a vertical transverse axis. Now, how do you find A, B, and C? You're going to need to find those. So very similar to the ellipse, except here we have c squared equals a squared plus b squared. Because if you remember, we have the Pythagorean theorem from the picture. And of course you have the center also to be h comma k, as in the ellipse and the circles, and the vertex of a parabola. And then we have just a quick visual here. Remember, you need to find c in order for you to find the distance from the center to the focus. And remember, a, right, the a from the a squared, the base, is going to be your center to the vertex of the hyperbola. And then along with finding not only the standard form for hyperbolas, we're going to also have to find the asymptotes for the hyperbola. So there are some asymptotes, and you need these two equations here. Notice here that the first one is a transverse axis that's horizontal, and then the other one is a transverse axis which is vertical. Now the only difference is the b, the constant, the b over a, or the slope. It's going to be the b and the a. For a horizontal one, it's going to be b over a. For the transverse axle being vertical, it's going to be a over b. So this is what they look like right here. You have a horizontal transverse axis, so everything opens to the right and to the left. So then we have these asymptotes here. We have these asymptotes. And then just a thing to point out here that is on this picture, this thing called a conjugate axis. Sometimes it's given to you, or you need to find the conjugate axis. But all you got to do is, from the center to the vertex, that's going to be the distance a. But in the conjugate axis, it's going to be the center moving up vertically the distance b. And that's going to create this square, right? And then, of course, the asymptote is going to go from edge to edge on both sides. Notice how you have a plus or minus over here. So we have two asymptotes. Okay, so let's go ahead and do this example on finding the standard form, right, of a hyperbola, and then we're going to go ahead and just graph it as well. Okay, so I'm going to go ahead and pause while you guys put this into standard form, and then I will go over the solution with you. Alright, welcome back. So I went ahead and I put this into standard form, and this is what we have so far. I'll go back over here. So again, we started off with the original equation. I rearranged them to where I put the x's together, and then I moved the 16 over to the other side because it has to be equal to 1, so I move all the constants over. I went ahead and complete the square for the x because there's no completing the square for the y, it's only y squared. So that's where I got here. And then I went ahead and I'm going to skip to this line where I distributed the 4, and that's how we get that minus 4. And then down over here, after you move the 4 over, you get negative 12. Now when you divide by the negative 12, don't forget to keep the sign, because that's going to change our expressions. The x's were positive, but now they become negative, which is what we have here. And then I wrote it in this form just so you can extract the information that we need. So what is the center? The center is going to be hk, which in this case is negative 1, 0. A is going to be the first constant under the leading expression, which in this case it's a y. It's under the y, so a is going to be 2, and then b is going to be the square root of 3. So one thing I do want to point out here is we want to write them as an expression over a squared and then over b squared. So because we have 3 here, remember this becomes negative, so that's why this expression moves over to this side. The way that we get 3 But the way that we put it into a square is you take the square root. So it's easy when it's 4, because the square root of 4 is 2, and then if you square it, you get back 4. So when it's, because we have 3, it's going to be 3, the square root of 3, because if you square that, you're going to get 3 back. If you square the square root of 3, you get 3 back. So that's how we got the square root of 3. So then from there, we have A is 2, B is the square root of 3. Pythagorean theorem, we get C equals to the square root of 7. So that means that our asymptotes, right? Our asymptotes, because our transverse axis is vertical, then our asymptotes are y equals k plus or minus a over b, x minus h, which in this case we have y equals k, which is going to be the y value, which in this case is 0 plus or minus. We got a was 2, b was the square root of 3, and then x minus h, which in this case is x plus 1. So then y equals plus or minus 2 over the square root of 3, x plus 1. So these are the equations of your asymptotes, which in the picture to the left is going to be the positive one, positive slope, and then the negative slope. And then you can see from here the stuff that we calculated. This is our center, which we got negative 1 comma 0, and then this distance right here to the vertex is a, which in this case a is equal to a is 2, so you move 2 units up. That's why the y moved 2 units up. And then c was from the center to the focus, which is why you move square root of 7 units up. And then you can do the conjugate axis. In other words, this point right here is going to be the square root of 3 moved over from the center. All right. Okay. So I hope this helps you to take a general equation, put it into hyperbola, and then you can extract all the information like we did for an ellipse. So you have a general equation here, ax squared plus cy squared plus dx plus ey plus f equals 0. Now before you start combining the x's and the y's and completing the square and all that good stuff, well, if you have these scenarios right here, you can find out if they are circles, parabolas, or ellipses just by performing these simple operations. All right, so let me do this real quick. So I'm going to take this guy. All right, and put that over there because we have a couple of examples. So if a is equal to c, we have a circle. If you multiply a times c, you get 0. In other words, if there's no a, or if there's no x squared and there's no y squared, then it's going to be a parabola. That's how you get 0. And then the ellipse is when you multiply them and you get a positive number. Obviously, the equation is plus. And when you multiply them and you get a negative number, then obviously it is a hyperbola because that's the only one that has a negative sign. So if you look at these guys real quick, if you want to go ahead and pause it, perform the operations, right? A times c is 0, so we have a parabola. We have a negative value, so we have hyperbola. A positive value, we have an ellipse. And then where they are the same, then you have a circle. And this is before you even begin doing the whole completing the square. I hope that example I did helped. If you need to see some more, please reach out to me. I have no problems creating a Google Hangout or a Zoom just to go over some more. Have a good day.